Commissioning of the 300-ton per day reverse osmosis plant with 2 trains. A reverse osmosis plant is a sophisticated water purification system designed to remove dissolved salts, impurities, and contaminants from water using the principle of reverse osmosis. It is widely used in industries, municipalities, and commercial applications for desalination, wastewater treatment, and producing high-purity water. Below is a detailed explanation of the RO plant, its components, operation, and commissioning process. Introduction to reverse osmosis technology. Reverse osmosis is a membrane-based filtration process that uses semi-permeable membranes to separate dissolved solids, ions, and contaminants from water. By applying pressure greater than the osmotic pressure, water molecules are forced through the membrane, while salts, organics, and other impurities are rejected. RO is highly effective for treating brackish water, seawater, and industrial wastewater. Key components of a 300-ton per day RO plant. A 300-ton per day RO plant with 2 trains consists of the following major components: pretreatment system. The pretreatment system is critical to protect the RO membranes from fouling, scaling, and damage. It typically includes multimedia filters, remove suspended solids, silt and turbidity. Activated carbon filters, remove chlorine, organic compounds, and odors. Chemical dosing systems, add antiscalants, coagulants, or biocides to prevent scaling and biofouling. Cartridge filters, fine filtration, 5 to 10 microns, to remove any remaining particles before water enters the RO membranes. High-pressure pump. The high-pressure pump provides the necessary pressure, typically 150 to 400 psi for brackish water and 800 to 1200 psi for seawater, to overcome osmotic pressure and push water through the RO membranes. The pump is designed to handle the required flow rate and pressure for the system. RO membrane array. The RO membranes are the heart of the system. They are arranged in pressure vessels, with each vessel containing multiple membrane elements. For a 300-ton per day plant, the membranes are divided into 2 trains, each capable of producing 150 tons per day. Common membrane types include spiral wound polyamide or thin-film composite membranes. Post-treatment system. pH adjustment. The permeate, purified water, may have a low pH, so it is adjusted using chemicals like caustic soda or lime. Disinfection, UV sterilization or chlorination is used to ensure the water is free from microorganisms. Remineralization, minerals may be added to improve taste and make the water suitable for drinking or industrial use. Control and monitoring system. The plant is equipped with a PLC, Programmable Logic Controller, or SCADA system for automation and monitoring. Key parameters such as pressure, flow rate, conductivity, and pH are continuously monitored to ensure optimal performance. Reject management. The concentrated brine, reject, from the RO process is discharged or further treated to minimize environmental impact. In some cases, the reject is sent to an evaporator or solar pond for disposal. Operation of the RO plant. The operation of a 300-ton per day RO plant involves the following steps. Pretreatment. Raw water is pumped through multimedia filters to remove suspended solids. Chlorine is removed using activated carbon filters to protect the RO membranes. Antiscalant chemicals are dosed to prevent scaling on the membranes. Pressurization. Pretreated water is pressurized using a high-pressure pump. The pressure is adjusted based on the feed water quality and desired recovery rate. Reverse osmosis process. Pressurized water is fed into the RO membrane array. Water molecules pass through the membranes, while dissolved salts and contaminants are rejected. Permeate, purified water, is collected, and reject, concentrated brine, is discharged. Post-treatment. The permeate undergoes pH adjustment and disinfection. Minerals may be added to improve water quality. Monitoring and control. The system is continuously monitored for parameters like pressure, flow rate, and conductivity. Alarms and automatic shutdowns are in place to protect the system from damage. Commissioning of the RO plant. Commissioning is the process of testing and ensuring that the RO plant operates as per design specifications. For a 300-ton-per-day plant with 2 trains, the commissioning process includes pre-commissioning checks. Inspect all equipment, pipelines, and electrical connections. Verify that pre-treatment systems are functioning correctly. Ensure proper installation of RO membranes and pressure vessels. Initial startup. Flush the system to remove any debris or contaminants. Gradually increase pressure and flow rate to avoid damaging the membranes. Check for leaks and ensure all valves and instruments are functioning. Performance testing. Measure the permeate flow rate, recovery rate, and rejection rate. Verify that the permeate quality meets the required standards, e.g., TDS less than 500 ppm for drinking water. Test the system under different operating conditions to ensure stability. Training and handover. Train the operators on system operation, maintenance, and troubleshooting. Provide documentation, including operating manuals and maintenance schedules. Key design and operational parameters. Capacity, 300 tons per day, 12.5 tons per hour. Recovery rate, 50 to 75% for brackish water, 30 to 50% for seawater. Rejection rate, 95 to 99% for dissolved salts. Feed water quality, TDS, pH, temperature, and turbidity must be within specified limits. Energy consumption, typically 3 to 10 kilowatt-hours per ton of water produced, depending on feed water salinity. Challenges and solutions. High energy consumption, use energy recovery devices, ERDs, to reduce energy costs. Membrane fouling and scaling, regular cleaning and proper pretreatment are essential. Brine disposal, implement environmentally friendly disposal methods, such as evaporation ponds or zero liquid discharge, ZLD, systems. Applications of the RO plant. Desalination, converting seawater or brackish water into potable water. Industrial water treatment, providing high-purity water for boilers, cooling towers, and manufacturing processes. Wastewater reuse, treating industrial or municipal wastewater for reuse. Drinking water supply, producing safe drinking water in areas with limited freshwater resources. Maintenance of the RO plant. Regularly clean and replace pretreatment filters. Monitor membrane performance and clean or replace membranes as needed. Inspect pumps, valves, and instrumentation for proper operation. Conduct periodic water quality testing to ensure compliance with standards. A programmable logic controller, PLC, is the central control unit in a reverse osmosis, RF, plant, responsible for automating and monitoring the entire system. It ensures efficient, reliable, and safe operation by controlling various components, such as pumps, valves, and sensors, while providing real-time data for decision-making. Key functions of PLC in an RO plant. Automation of processes. Controls the start/stop sequence of pumps, valves, and other equipment. Automates pretreatment, RO filtration, and post-treatment processes. Manages backwashing of filters and cleaning of RO membranes, CIP, clean in place. Monitoring and data acquisition. Collects real-time data from sensors, e.g., pressure, flow rate, conductivity, pH, temperature. Displays operational parameters on the human-machine interface, HMI, or SCADA system. Safety and alarms. Detects abnormal conditions, e.g., high pressure, low flow, membrane fouling, and triggers alarms. Initiates automatic shutdowns to protect equipment and ensure safety. Energy optimization. Controls the operation of high-pressure pumps and energy recovery devices, ERDs, to minimize energy consumption. Remote control and diagnostics. Allows operators to monitor and control the plant remotely via SCADA or web-based interfaces. Facilitates troubleshooting and diagnostics through real-time data and historical trends. Components controlled by the PLC. Pretreatment system. Multimedia filters, activated carbon filters, and chemical dosing pumps. High-pressure pump. Controls pump speed and pressure to optimize RO performance. RO membrane array. Monitors pressure, flow rate, and conductivity across the membranes. Post-treatment system. pH adjustment, disinfection, and remineralization processes. Auxiliary equipment. Backwash pumps, cleaning systems, and reject management systems. Key parameters monitored by the PLC. Pressure, feed pressure, membrane pressure, and reject pressure. Flow rate, feed flow, permeate flow, and reject flow. Water quality, conductivity, TDS, pH, and temperature. Energy consumption, power usage of pumps and ERDs. Benefits of PLC control in an RO plant. Improved efficiency, optimizes plant performance and reduces energy consumption. Enhanced reliability, minimizes human error and ensures consistent operation. Real-time monitoring, provides instant access to operational data for better decision-making. Reduced downtime, early detection of issues and automated maintenance routines. Scalability, easily adaptable to changes in plant capacity or process requirements. The PLC is a critical component in modern RO plants, enabling automation, monitoring, and control of the entire system. It ensures efficient and reliable operation while providing real-time data for optimization and troubleshooting. With advanced PLC systems, RO plants can achieve higher performance, lower operational costs, and improved water quality.